recording. So you'll notice from the schedule what we're going to be trying is Project 4 MASH. In the original schedule, I gave you a week for that, but that was because I was trying to squeeze it in before fall break. I don't want to try to squeeze it in before fall break anymore. We're going to go ahead and extend that deadline a little bit until after fall break, but we'll talk about the actual final deadline before the end of class here. Right now, I want to introduce you to it and get you playing with it, because most of this is one of the most open-ended assignments I give in this class. So let's open up Maya, a fresh new Maya scene, and let's just start playing in here so you can see how MASH works. We're not making anything specific. I'm actually going to make half a dozen different specific things, right? Or not specific things, half a dozen different things. Okay. Yes? Click that. So let's create an object. It can be whatever you want it to be. I'm going to do a cone, so I like cones. And just to give me like something a little spikier, I'm going to do something like this. Okay, so I have a cone. That's all you really need to get started in MASH is some form of object. So what we're doing is what we're going to be doing with MASH is called procedural animation, right? So think of it like two opposite ends of the extreme. With keyframe animation, I am in complete control of every frame of the animation using keyframes and the graph editor, right? If I need my ball to shift ever so slightly to the right, I can change the keyframe, I can change the curve. I am in complete control and I predefine the path of that, right? Simulation is the opposite, right? Like it's the Clockwork Universe version of it, right? You place everything, you twist it around, you dial in some numbers, you hit play and you pray, right? Like you hope it works. Like, is this gonna do it? Didn't do it. Now what do I need to do to make that simulation work the way I wanted it to do? Simulation is sometimes unpredictable, even though it's based on math, right? It's based off of physics. What you think it's going to do isn't always what you think it's going to do. If any of you remember from the cereal project, trying to get all of the cereal into the bowl is really sort of how you sum that up, right? It's so difficult to get all of that cereal to land in that bowl. So much so that like one semester I was doing the demo in class and it happened the first time and it was like a freaking miracle. Like I wrote it down because I just got 2 more to go and I'll be a saint, right? What we're looking at today, procedural animation, is sort of in between that, right? It's not completely simulating using physics. It's using a series of algorithms or a series of processes to get motion out of the object, right? So for example, let's do a brain exercise here. You all know what a sine wave is? Like it's that constant up and down wave, right? So just imagine I hooked my objects translate y to that sine wave, right? What would happen is my objects would just go up and down at a regular interval, right? What if I hooked my objects scale z to that, right? My object would scale up and down at that same increment of the sine wave, right? It's using math to drive those values of where that object is, right? That's procedural animation. So what we're going to do, it's not simulation, it's just using sort of the power of how numbers can add up over time to make motion. The biggest reason to use this, like it's very easy to set 2 keyframes and get that sine wave, right? The biggest reason to use this is when you need to animate masses of things, right? It's very similar to simulation. You want all these blocks to fall out of the side of this building, and you don't want to keyframe every one of those. Well, what if I just want a lot of these little cones sort of flying around in a circle randomly, right? Like I would have to keyframe every one of them and do it would just take forever, right? So what I'm going to do is sort of show you how MASH works. I'm going to go ahead and move this up. So we just need an object to start with, right? MASH is going to create a system of objects off of this object. So you'll see right here, I'll actually name this one, original cone, right? So it's right there. I'm going to go to my animation menu. I'm going to go to MASH. And I'm going to create a MASH network. And as soon as I click that, I'm going to get 10 cones. Okay? Yep, it's a cone multiplier. So you'll see a couple of things that happened. My original cone is now invisible, right? It's still there. In fact, I can move it around, or if I scale it, it'll probably actually adjust my original one, right? But it still exists. And then I get this MASH repro mesh. So this is MASH reproduction mesh. So it's basically reproducing my object 10 times and creating a new mesh out of that, right? And you'll also see this MASH 1 object down here at the bottom. Now, if I go to my attribute editor with that MASH 1 node selected, you'll see that I get this, right? Which is a bunch of nice icons that don't make sense. We'll talk about some of those in a minute. For this to make sense, we need to open our MASH editor. So if we go to MASH editor, this is where like all of the different nodes that we are going to plug into this start taking effect, right? So when I first created my MASH network, what it basically did is made my MASH 1 distribute node, right? I may be wrong on this, but I don't think I am. MASH distribute node is like something that has to be there for MASH to work, right? It says you have that one object, now we're going to start doing a whole bunch of stuff with that one object, and this is how we're going to distribute it. Now, you'll see that if I click this MASH distribute node, or if I click this MASH 1, it's right here, MASH 1 distribute, right? You'll see that I have some things I can change about this. If I don't want 10 objects, I just want 6 or 4 or 5, I can change that. Or if I want 100, I can change that, right? Right now I have 100 that are separated by 20 units on X. I can stretch that out. And I can have 100 that are separated by 100 units on X. And so now I have 100 of those cones, right? You'll notice that the way it's distributing it is in a straight line. It's because of this next drop-down box down here, which says, how do you want to distribute it? And I've said linearly, right, across a line. If we click on that, you'll see that I get a lot of different options. Get radial. Right, so basically what it's doing is it's taking its location and it's distributing it around a circle, like in a radial pattern, right? I can change the size of that radius. I can change, I'm gonna move this off to the side here. I still don't need it, but I can change the size of that radius. I can change the angle of it, where I'm just doing half of an angle. I can offset it in Z. So I could set this, instead of to 360, I could set it to 800 and get something like this. And so I'm just distributing all this, and it's still all very interactive. I can turn it up, turn it down, make my radius bigger or smaller. Right? I can go here. There's a whole bunch of different options. I can do spherical. It's kind of hard to tell what's happening here, but it's organized them around an invisible sphere. See that? And I can, you can try all these. Mesh means I can align them onto a mesh, which means you could use this to populate a terrain with a bunch of trees, right? And kind of dynamically drive up and down that number of trees that are on that terrain. So just right out of the box, it's a nice way of duplicating objects in procedural ways, right? Like you can do all sorts of stuff. One I like is grid. So grid is interesting. It puts them a number of grids. So right now I have 3 by 3, and it's the distance between each of them is 5 units. I can make that 25 by 25, make the distance 50 units by 50 units, and I get a really nice bed of spikes there. Again, at any point that I'm like, you know what, I made my spike a little too tall, I can always go back in here to my original spike and sort of scale it down a little bit, right? So I have all of these objects, but that's just the first step, right? Getting all of these objects is not the end goal. I mean, you can always, it's always great if you're like, oh, I needed a bed of spikes. Now you have a bed of spikes. What if you needed something else, right? Because we haven't really even added any motion to this. So that's where this becomes kind of neat. Like, I could have animated that original spike, and what I would get is a repeating animated version of that 50 times by 50 times, right? But instead, I'm going to even make my animation procedural, okay? So I want each of these spikes to animate a little differently. So again, with my mesh node here, you'll notice that I have mesh and then I have this distribute layer underneath. Under the mesh 1 node, this is where I can start adding additional effects to it. Now, some of these are going to cause motion, some of them are not. So let's just try one randomly. Let's try this flight node. And so if I click that, add flight node, it gives me this really like weird sphere. Right? This is sort of like a sphere of influence. And if I hit play, they're all going to fly around sort of randomly. Now, the hard part with the flight node is kind of like corralling all of these things. But if what you need for your animation is a school of fish, like we've pretty much got most of that underway, right? Like we've got something that is sort of following the same protocols of most flocking systems, right? Yes?
You're recording this, right?
I am. I think I am, yes. I will say it does not seem to be updating in the recorder very well, though. Hopefully that's actually still recording well. So we get this system of objects flying around. I'm going to go ahead and hit stop. Well, actually, no, I'm going to go ahead and let it play. So one of the reasons this is procedural is I can make changes to this, right? Number of companions right now is set to 50. If I turn this up to 100, what does that look like? It changes it a little bit, nothing significant, right? I'm going to put that back to 50. You'll notice search distance. This is the distance it's going to look for other companions to follow. And so I can extend that a little bit more and sort of changes the simulation a little bit. Cohesion strength. I think that's how much they're going to stick together. So now they're kind of trying to follow the center of this a little more, right? Alignment strength, like I can turn that down, way down, and see what even happens there. Right? It seems like they kind of crash through each other a little bit then. That might have been the cohesion strength, though. So we can just sort of pull that around a little bit. Now let's say I don't want them to quite try to separate from each other quite as much. That's just separation strength, right? Just turn that down a little bit. And so there's a lot of different things we can adjust here. And this is not a simulation. This is not using physics to drive this. It's using just a bunch of different numbers to calculate a system. Is that making sense? Like what's kind of happening here? Now what I've done is I've just done a distribute node where I made all of those different cones, and then I made this flight node simulate them all sort of traveling around in semi-random trajectories, but still trying to stay near each other. I did that just by adding one node, right? So where MASH gets really powerful is when I go over here to MASH 1, I can start layering these on top of each other. I can add other nodes on top of that, right? There's a color node that will cause the objects to dynamically change colors based off of certain attributes. There's an offset node that will allow things to kind of drag behind one another, right? There's all sorts of different, there's a replicator node that would basically take this entire system and duplicate it over and over again. So I could have like 30 different flocks of fish all in one big system. And if you needed to get like gnats or something like that, then maybe that's what you would want, is like a giant swarm of these things. So these are all just based off of these nodes, and the cool thing about it is if I don't like that, I can just turn it off and I'm back to my distribute node, right? Or I can right click on this and delete it. So I'm going to go ahead and delete my flight node, and we're going to try a different one. This is sort of my base go-to. I need a little bit of motion. I'm going to use a signal node. So this is very much like what we were talking about earlier with driving stuff with the sine wave. So how I deleted that flight node, if you were curious, I just right-clicked on it and hit delete. And we can always add that back on there later if we want to. So go to Mash 1 here. I'm going to use this signal node. So again, I'm going to right-click on it, add signal node. And it looks like everything got kind of crazy, but if I hit play, you're going to see that they're all just kind of wiggling. Right? That's like wiggling spikes. Right? So what this is very similar to what I was saying earlier. It's like taking a sine wave or taking some like algorithmically generated wave, right? And using that to drive certain attributes. What we have over here is where we get to determine which attribute that is, right? So, for example, I can choose my signal type as right now 4D noise, which means it's like more than one dimension of noise. I can do looping noise, and it's a really slow motion, and it's also really small. So to be able to see that, maybe I need to crank up my position Y, right? Or I need to crank up the noise scale. And so what you see is happening is whatever is in here, like trigonometry, right? It's driving whatever I have listed here. If I wanted it to just move it up and down, I can turn down my position X and Z, and it's just driving my position Y. Right? That's trigonometry. If I wanted to do 4D noise, oh, I need to scale that back. What was it at originally? 1? Yeah. So this is 4D noise kind of randomly on there. I could turn position Y up more, and it's just going to... Now I have a gougy bed of spikes. Recognize that this is just if I wanted to use translates. Right? I don't have to make this translate at all. I could instead turn my translates all the way down and go in here and start turning up my scale Y. Right? And, for scale to work, you have to uncheck this uniform scale. And so maybe that's a little much. Let's turn it down a little bit here. You're going to see that it's like scaling them up and down, right? Or if I wanted to turn that all the way off and I just wanted a side-to-side scale, get something like this. I'm going to uncheck. Yeah. So we're getting some very like procedurally generated things here, right? Turning all my scale down, I can do this with rotation. Right? If I wanted to do it with rotate Z, now I'm just getting these like, they're just wiggling, right? Okay. Again, this is the sort of the first layer of this. I start adding these things onto it, and then I try to add an additional layer on top of that to make it more interesting. Because it's almost like we can see the man behind the curtain in this one a little bit, right? It's like, oh, those are all just randomly rotating in place, right? And where stuff starts to feel more natural or more organic or more interesting is where it seems like it's kind of making decisions on its own, right? So let's go ahead and turn this down again. Actually, I'm going to go ahead and delete my signal for right now. Oh, I think I did that wrong. Yeah, I did that wrong. Right click on that, delete my signal. And so I have, again, this set of stuff. I'm going to go back to my distribute node, and I'm going to set this up. Right now, let's do it linearly. And I'm going to do it linearly along my, Y, I think. There we go. And yeah, let's do something like that. Just for right now. I'm going to go ahead and add another distribute node on there, or another signal node on there. So signal, add signal node, and you see that we get sort of this weird jumble of stuff here. I'm going to spread them out a little bit more. Something like this. And maybe scale down my size of my, oh, that's not that. The noise scale just a little bit, right? So a little bit more like this, right? Now, you'll see under here we have a couple of other things. We have this curve node, we have an audio node. We can plug in a soundtrack and we can make these things move to specific beats of the audio. I'll be honest, I've had a little trouble getting that to work exactly the way I wanted it to, but it works. We have a trails node. So let's try some of that. What I'm going to do is I'm going to create a curve here in Maya. I'm just going to go ahead and hit stop. I'm going to go to my front view. And I'm just going to draw out an interesting path for these to fly around in, right? So I go to curves. Maybe I'll use my pencil tool. And I'm just going to draw a curve, whatever. Let's do, here, I'm going to do a cursive G, because my name's Greg. There we go. Got a nice G, right? So we can use this curve to kind of guide this motion, right? If we go back to our mesh, we have this curve node, add curve node. It seems to have found it. I don't know how it actually automatically, I think it's because I still had it selected when I created that curve node. If you don't have that selected, I can show you how to do that differently. So if you go to this and you add the curve node, you're going to see that my input curves are empty right here, and when I hit play, nothing happens. The way you do that is, with this still selected, you have to middle click on curve 1. Don't regular click, but middle click and drag that over into this input. And so now they go wiggling around there, right? Actually, I can probably go back to my distribute node now, and I don't think I really needed them to go too far along that distance Y. So now they're going to creep along this curve, right? So there are settings on the curve as well, right? I can adjust the animation speed to make them go faster. Time step variation, so some of them are going to go faster than others. And now they're just traveling around this G. They're traveling pointed in the wrong direction. But that's where this up vector comes from. Right now the up vector is Y. I'm just going to hit that to 0 and try one of these others, maybe X. I thought that's what it was. No, apparently I was wrong on that. There are other ways we can adjust this though, and really for me, if this were what I wanted was for it to follow along that path, probably the easiest way would just be to go back to my original object and rotate it. until they were sort of following along the path. I think it would be that way, right? And so now I get, and if I wanted to hide that curve, I get these objects that are following a very specific path, right? And I think it's actually pretty cool because we can still add some noise to this. We can add some velocity noise. And in my distribute node, I can still add a little bit of distance if I wanted to. Is it Z and Y to get them separated apart a little bit? Or I could do a little bit of that in the signal, right? So if I wanted to separate them even more in X and, bless you, X and Z, and all of them, I could crank this up to more like 30, 30, 30. And now they're going to fly a little, like, it's a little less nice looking though. So I'll probably go ahead and take that back. Okay. Just looking to see if there's anything else neat in here to kind of show you. Okay. So my instinct at this point is to ask, is that making sense? But it probably makes sense conceptually, but like it's kind of hard to like teach or plan for, right? It's like, I'm sure once you work with this for years and years, it's very easy to see how you would solve specific problems, and you would come up with a plan, this is how I want it to work, and you would just go in there and drop in the 4 nodes to make that execute, right? Like I've gotten better at it, and I've solved problems that you would not imagine would be good to solve with this. Like we did tank tread with this. You can create duplicates of a certain object, make them distribute along a curve at a certain interval, and it was a quick way of distributing tank tread along a path. It's not the only way of doing it, but like this is really what this is. Hopefully at this point, what this is the best at is giving you something to play with, right? And so we'll talk about the assignment here in a minute, but that's one of the reasons I make a very open-ended assignment. I think there's like 4 or 5 different options you can choose from on this, and I just want to encourage you to take some time and just try to make something cool with it, right? Let me find this file really quick here. In the past, I've used this in other classes, just tinkering around with it, see what I can come up with. And where are those? Let me show you a few examples. It's undergraduate class. No, it's not. Here we go. So just a couple of things I've just tinkered around with in the past, gotten out of this was stuff like this, which I thought was a very neat little attempt at something. And some of this is just how did I render it? How do we place our camera to get something that is intriguing to look at, right? I did a handful of different versions of this, trying to make it work the way I wanted it to, and got different results with this. And I think this is probably looking much more like what I was thinking of. So stuff like this, very quick results on this. I'll show you some interesting things with these lines here in a second. And this one, right? Now, And you probably recognize certain parts of this being the flight node just on some cylinders. But you get these little tails on them too, right? So let me just show you that. Like, this is actually a really easy way of doing this. It's another one of your MASH nodes here. We have this add utility. We have other stuff down here too, but really just these first two are where you're going to find most of the things you want. And what I used was trails. So I click on that, add trail nodes, and skip frames too large. If I hit play on this, it's really hard to see them unless you zoom in, but you'll see that they're dragging these little strings along behind them. So we can make changes to those strings. So we can do the trail length, the trail scale, stuff like this. So now they're going to start writing out my name a little, or writing out my first initial a little more clearly, right? There's all sorts of little things. We can have decay on the trail, so it kind of, I think that means it starts kind of disappearing over time. I'm not really seeing that, but there we go. Yeah, pull it back a little bit more, I think, for that to happen. And there's just a lot of different elements we can change on this. The other thing I can do with trails is I don't have to do trails. I can do these different elements, this join the dots thing, and it's going to like kind of connect objects together, connect to points. It's like connecting it all the way back to the origin. Connect to nearest, which means like as they get close to each other, they're going to connect each other like with a little line. Right? Connect by distance. I don't know. Like we can just try out constrained pairs. I actually like just the normal trails in this case. And sort of the way it writes this out, right? Let's see that quite as well up there. So again, this project, I want you to kind of play around with it. So much so that I also don't really want you worrying about rendering that much. So I want to take a minute or two here to talk about a couple of rendering alternatives for you. Maya changes so much every semester. And I know that in principles, like the first thing you hear is like, use Arnold because Arnold's the only good one, right? That's not always the truth, but the reasons to use Maya software are increasingly fewer and fewer. There is one, though, that works pretty well. And when I taught this class last semester, that was my go-to to show you how to get a quick render out of this that has this solid tune look to it, right? Like this shape. Since then, Arnold has released another iteration that has another version of this that works even better than this, with all of sort of the standard Arnold tools, but it doesn't render nearly as fast as this. So I want to show you some of that, but then I'll also show you the Arnold version, and then we'll kick off the assignment and let your brain start chewing on some ideas for this, right? So the way I did this is with the legacy tune shaders that are in Maya. So you may not even know that Maya has some cartoon shaders, but they do. If I go to rendering, it's under tune. So I can grab these objects. Let's say I grab this repro mesh right here and go tune. I can add a fill shader. And that shader can be a solid color, it can be two-tone, it can be tune-tone driven by the brightness. Let's just do, or it can be three-tone. And so when I grab that, you see what happens with three-tone is it gives me a shader that's going to render like that. Now, if I go in here and render with Arnold, which is what's going to render by default, I get nothing. Right? This is really the only time I ever use Maya Software Renderer. So if I go to Maya Software right here and render again, I start getting these, getting this as the render. Right? Now there's a lot of stuff I would want to change in here. I would go in here and definitely make this a different file format, so probably PNG. And I want to make my camera size much bigger, HD 1080. And then under here, I also want to make sure, right now it's the lowest quality render. I would just go ahead and put this up to production quality. And if I render again, it's going to render pretty quickly. And we get some kind of neat effects out of that, right? Now to change this toon shader colors, I just have to go in here on that material. And I just get this brightness range, and I can just change each of these colors, right? So I can leave that one maybe, let's do like this instead. I'll go ahead and double click on this, set it to green, double click on this, double click on this one, set it to blue, double click on this one, set it to red. Oh. And so now I get this kind of trippy RGB thing going on, right? And if I render with Maya Software, again, it'll get an okay render out of this. I have this completely black background, which is sort of sucking any energy I happen to have out of this. And that's going to be in Maya Software connected to your camera. So if you select your camera, we can go down here to our background. Let's see, it's under Environment, Background Color. And I can just choose whatever color I want. Let's try a more or less saturated sort of orange.
Whoa, boy. That's phenomenal.
Okay. We can also add a different material to the tail if you'd like. And with the objects themselves, we can add a stroke to that. So we can go here to Assign Outline, add New Toon Outline, and each of these should render now with stroke around them. Give it a second here. This material here, I'm going to go ahead and assign a new material to it. We can do, again, whatever we really want to with this. You can add another toon material to it. Let's try that. Let's add a fill shader. I'm going to do solid color. It's very white. And then out glow color to give it a little bit of a glow. Sort of make it a little bit more peach color. Let's see what that does. I was kind of hoping to make it more like glowy outlines. But again, any sort of, oh, there we go. Okay, so the glow is going to render as an after effect. So I render again. This render speed isn't that fast, like it can be faster, but it's giving us something kind of quickly out of this. You'd also probably want to turn on some motion blur on this, but we can get a relatively interesting effect that's not photorealistic kind of quickly out of this. I'll say that this was my go-to whenever I needed something non-photorealistic for a long stretch of time. And last semester, or last iteration of Maya over the summer, Arnold introduced their own toon shader. So I'll show you that because it's just a little more robust. So let's actually just make an entirely new scene here. File, new scene, don't save. Just so you can see how this works. Because it has all of the usable parts of Arnold with like the high quality render and the light quality. It just takes a little bit longer to render it. So I'm going to do this, switch over to Arnold. We are pretty familiar that if I render now, nothing's going to happen because I need a light in there. I hate the sky dome light, so I'm going to use the mesh, or I'm going to use an area light, and move it around, something like this, normalize, duplicate it. So I'm just getting us a little scene in here. Arnold render view, hit play. So this is what we're getting, just sort of default out of Arnold, right? So I'm going to go ahead and add a new shader to this, just so we can see how these shaders work. I'm going to select both of these objects, right click, assign new material, and under the shaders here, it's this AI toon. And when I render, it's not really going to look that much different. It's a little glowier, but not much has changed, right? It works a lot like all of the other Arnold shaders. If you select it and look at it, you'll see that some of this stuff's going to be similar, base, specular, all of that. We also have these edge detection. But first things first, we want to be able to see some outlines around this. So the only way for that to work is if we change in our render settings. We go to this Arnold Renderer tab, and under sampling and filter, currently it's set to Gaussian. And if I set that to contour and hit render, it's going to render an outline around it. Okay? So it's just going to find my edges on my object and render an outline in this color. So if I want to change this just so we can see it a little bit better, there we go. Let's change it to something different. You'll start to see that we can add internal edges as well, like it's not drawing the edges along this part of the box. And that's going to be under this angle threshold. So as I start to lower that, pretty much I'll start seeing that once I get it below 90 degrees. Once I go over 90 degrees, it doesn't recognize that as an angle it needs to draw. Right? And so we can get down here and start getting this. And there's some stuff we can do in here too to make these lines have a little bit more interest. But what I want to show you is down here a little lower under our base color. So right now my base color is just set to white. I'm going to change this to something where we can kind of see it, maybe sort of a light pinkish purple here. Is that all right? Maybe I just need to turn my lights up. Turn my exposure up there a little bit. There we go. Maybe that's a little too much. And make that a little more on the, there we go. So that's my base color of my my object here, right? But right below base color is tone map. So I can go to tone map and click out here. And what this is going to do is it's going to look for something to give me an indication, or to give Maya an indication on how to break up your cell shading, like those like bands of color. And if we click on ramp, it just immediately goes black, right? That's because right now it's set to all be kind of this either black or white. And if I scale this, you'll see I get like, I can sort of pull this closer together and get a little bit more of a toon-ish look, right? But if I set this to none instead of linear, I get these solid lines. And then if I select my black color here and start taking that more toward gray, I start getting a darker shade of the color I already had, right? So I can go here again, make this one a little darker, and I can start making these bands of color. Now, the cool thing about this versus some of the other toon shaders is that this is driven by light, right? Which means if I go in here and start adjusting these lights in this scene, these shadows will react accurately. So, not shadows, the parts of the box, right? The other cool thing about this is all of my other material options inside of Arnold are still there as well. So I can still have these be reflective and a toon shade. And even we get to see the toon outlines in the reflectivity if we wanted to. I can turn up the roughness of that reflectivity, and so I can start getting these like highlights on this. And we also get this option for something called rim light, which is kind of neat. If you turn that up to white, you'll see that my entire object kind of starts glowing. But if I turn my width down to like say 0.2, it really just puts like a little like halo around it. Right? So I can turn that up and down. Maybe put that to like 0.3, right? So this is not going to render quite as fast as the toon shader, but it is going to give you a style that is actually really popular in procedural animation. So I can just kind of tell you all are not as excited about materials and texturing. Let's talk about where you would use this. Like, where is somewhere you would, not the toon shader, but Mesh. Where's somewhere that you would use Mesh?
Made me think of like little particles that might have floating around characters and using magic to reveal the different objects.
Yeah, absolutely. Like if you needed to have embers of fire or whatever, like you said, like they're using magic and you want like little sparkles to like fly around them or whatever, we could do something with that. Where's somewhere else you would think to use it?
Get like meteors or asteroids in space.
Yeah, definitely. You could almost use it to fake some stuff and effects, right? Like because some stuff moves in what feels like a very procedural way. So. Other reasons you could think to use this?
Like waves and whatnot.
Waves.
Like things like NFX, like you were saying, like the waves in water or something. You could kind of fake that with Mesh.
Maybe, yeah.
The G actually made reminded me of like a quick logo.
There you go. So that's really why this was implemented in there. It's called motion graphics. And some of you have probably played around with a little bit of this in some of Livingston's classes. This is one of the branches of animation that is animation visual effects that is really growing everywhere. Like if you think about it, like your aunt opens up a cupcake shop, she wants a logo, right? But now everybody is also on the internet and they want something to advertise through Facebook or Instagram or whatever, and they want a moving logo, right? Motion graphics is basically graphic design that moves, right? And that's a huge industry right now. If you go out and look at all of the industries, that's a huge market right now. If you go out and look at all of the freelance jobs that are advertised in different places for animation, I would say probably 40 to 60% of them are some variation of motion graphics, right? It's to the point that people come to us at ETSU and ask for motion graphics artists, and we can't get people leaving the department fast enough to fill those jobs. It also means that like they're in high demand. You got to be able to solve problems creatively and make some interesting stuff. If this is something you're interested in, I really encourage you to work with it. MASH is Maya's version of motion graphics. A lot of motion graphics is done in After Effects, but there's also other tools. Cinema 4D has a lot of motion graphics tools. And if this is something you're interested in, like it's kind of one of those areas that falls in between visual effects and animation. And so it's something that you could do majoring in animation and taking some electives in visual effects, or vice versa, right? I wanted to show you some examples of motion graphics reels here in a second. Can anybody think of other things that you could use this for? Like, that's really, to me, the exercise for this project. What are some things you could use this for? Because that's what I want to get into your head, is that when somebody says, hey, we need this thing, and you like go to your toolbox to try to figure out how you're going to do that thing, right? Whatever project it is in the future, I want MASH to be in that toolbox, right? I want you to think, can I do that with MASH, right? We need a wheat field with a bunch of waving stalks of wheat. Can I do that with MASH? Should I do that with NCOF, right? That's really what this is like. Almost all jobs you're ever going to have, they're not going to pay you to repeat a process. They're going to pay you to solve a problem. And so that's where I want you to start like looking for it. What were you going to say?
Sorry, I was just going to ask, have you ever had someone try like animate a 3D press?
Not for this project. I've seen it done. Like there's other ways we could also do that. The real problem with animating something like that is that if it has too much detail in that blade of grass, it sort of bogs the computer down. I do think that it would probably be, you could probably do something like that with MASH. There's a couple of other solutions. There's a sort of a hair fur system that's kind of built into Maya. And my guess is you would probably use something like that if you wanted like a bunch of grass. There's also something in there called XGen, which I have a feeling is kind of being phased out by the hair system and MASH. But yeah, I do think like that's an interesting one. That may be something that you can kind of fit into this next project if it's something you want to try, right? And so that's really the thing is like put a challenge in front of yourself and say, I wonder if I can make that happen. Right? One of the challenges I liked was there's a really big it's almost like there are trends that happen in design, and I'm sure many of you have noticed recently that everything looks like Minecraft now, right? Like everywhere you go, like there's Minecraft cereal commercials, like everything, like that voxel look is a thing now, right? And so that is something we can make in MASH really pretty interestingly, right? I can crank this up to 50. I'm just going to put a couple of, what sort of deformers do I want to put on this? Let's put a animation deform. Let's put a nonlinear wave on this and crank up my amplitude a little bit. There we go, maybe a little too much. 0.05, there we go. And animate my offset from frames S. Oh, let's just do it on offset. Key selected. Set that up there to like 200. Key selected. So if I hit play, is that too fast? A little too fast. Let's make that more like 50. Key selected. You know what? Maybe that's still too high. Let's go to my graph editor and fix that. Animation editor, graph editor. Let's pull that one way down here. Let's try that. So we have this object that's happening here, right? Or this whatever that's happening here. I'm going to hide that just so we can see it. And then I have this box. So if I go in here to mesh, create a mesh network, and then I'm going to, let me go ahead and give that box a color before I do that, just so we can see it a little bit better. Assign new material, shader, we'll go ahead and make it, just for right now, this, no. Make it green so we can see it, right? So I have this box. I'm going to go to mesh, create a mesh network. It created 10 of them there. Instead of using linear, I'm going to use mesh. And the first thing it's going to ask is like, what mesh? Which mesh are we putting this on? I'm going to put it on this plane 1. So I middle click plane 1, drop it into my input mesh, and you're going to see it's going to distribute that box all over there. And if I wanted to put like 200 on there, now what I get is this of these meshes that kind of follow along there, right? Now the method in which it wants to put it on there, right now is set to scatter. I'm going to change that to voxel. And so that's kind of getting a little trippy looking. Let's go ahead and hide my plane just so I can see just what these are doing. Right. Number of points, can I crank that up even higher? So I may need to actually scale my original cube just a little bit. Fill in this shape. And so now we're getting kind of this this voxel effect on stuff, right? So like there's so many different things that we could do in this, and really like this actually has some more refinement you can do to it to where it doesn't pop quite so much, and we could also distribute a little smaller, make the adjustment a little bigger. So there's just so many little things that you could do with this, and I want you to like kind of use that to solve a problem. In TD, in technical direction, Marty uses, well, I don't know if he always does this, but sometimes Marty uses MASH to do crowd simulation, right? You animate a spider one time, and then you have hundreds of those spiders crawling along a mesh, right? Which freaks a lot of people out. So like, there's just so many little things you can do with this. So that's what I really want this project to do more than anything, is to get you to explore and to experiment with some stuff. So let's go ahead and look at the actual project then, because that's, some of you have probably already gone to look. I'll go ahead and stop it here, or stop my playback here. Open up D2L. I know I have D2L here somewhere. There we go. Assignments, projects. This is project 4. The project where I stopped using the word, I guess I didn't. I used a bobbin arm. There we go. So, first, why are we doing this? Not all animation is created with keyframes. You have to learn to leverage the tools at your disposal for solving problems. So you're going to pick one of the problems below and solve that problem using MASH. Okay? So this is where you get to be the creative one. You get to come up with a solution. Imagine a client comes to you with a bag of money, and she has 4 projects she needs completed. She says, pick one of the projects, and if the final result looks good, I'll give you this bag of money. So here are the projects you can pick from. An animated motion graphics bumper for the Dr. Enough logo. Anybody like Dr. Enough in there? Huh? Yeah, it's like it's like if somebody put some cocaine in your Sprite. That's what it's like. Do it.
It's supposed to be good for you because of the vitamins.
Vitamins.
Like, I think the sugar.
Yeah. I think the only vitamin in it is like caffeine. Like, I don't think that's a vitamin. Actually, if you go through Pals, you can get Dr. Enough with the peach flavoring in it. That's pretty good. So an animated motion graphics bumper for Dr. Enough logo, a silhouetted render of a flock of flying things taking off and/or landing. So imagine a flock of birds landing in a tree or something like that. Geometric objects dancing or moving to music. A trail of objects following each other across a terrain toward a specific destination. So think of the spider one, or maybe it's a bunch of roaches crawling off the edge of a table, right? An evolving voxel landscape. I kind of threw something in there for you just now. Or a school of fish swimming through the ocean. Okay. Each piece should be fully rendered in H.264 codec and between 3 to 7 seconds long. Okay. And the final rendered video will be due on question mark. Let's look at question mark. If I go back to my content here and look at our schedule. So as it is right now, I've built tons of extra time into our final project. So the BIMBot project, we have almost 5 weeks, right? Last semester, we got carried away, ate into some of that time, and they got it done in like 3 weeks pretty easily. So I don't think that it's going to be too big of a deal if we sort of start nudging this down a little bit. I also built a little bit of extra time into Project 5, the Hobo project. So my proposal is that this be due on the 23rd, so the Tuesday after we come back. So we come back, fall break is Monday and Tuesday of next week. We meet Thursday to have another in-class work day, and then it would be due the following Tuesday. How does that sound? Does it sound reasonable? Okay. So this is going to require some research on your part. So let's go ahead and put this date in here, though. And I need to update this as well. So 10/23/18, so it's Tuesday, October 23rd. So Tuesday, October 23rd. Okay. So what we haven't done yet is looked at some examples of motion graphics, right? And so I thought we would do that now. In the past, I would do it before, but I decided to kind of put it off to the end, let you think about this without any preconceived notions, and then look at what motion graphics artists are coming up with. So, is this the one I'm thinking of? No, it is not. Oh man. Let's try this one and see what's in here. I need to look for the. course, I found the motion graphics reel of somebody who doesn't know how to edit. So take half of that was like really solid examples. Some of it was a lot of explainer video stuff, which has got a good point too. But a lot of that was done in After Effects while I looked up some of the other demo reels I wanted to show. So this is a company's demo reel using Mesh. The same company did another one that was, I wonder if that was any good. See, this is how I end up watching videos that are not as good, is by randomly clicking on them. This is a different reel done by the same company. Turn that one down. So, this is, I will say up front, I love how a lot of these look. This is the style that will eventually date itself, but that day's not yet. So think about a lot of this is sort of a popular style right now, this flat shaded, extremely bright colored style. So think about that, like maybe do a little research on what you want the final thing to look like. And then what I would do is start taking stabs at getting there. It may not work the first time. You may be like, ooh, maybe what I do is add a signal and then I do this, and you start doing that. And like you'll get results like really quick, right? And then you can look at it and be like, I'm heading down the wrong path. Let me save this and start over again, right? And it may take 3 or 4 attempts to start getting the thing you want. But along that way, experiment. Try adjusting some numbers and seeing what that looks like. Right? And just start pushing for this. The goal of this, though, is to have something that looks finished. Right? To have something that looks like a solid piece. Again, I'm leaving this kind of open-ended so you can explore, but it needs to feel like something you would turn into a client, not something that you would turn into an exercise. Right? So work on trying to like get it all the way through to the end, including rendering, lighting, all of that stuff. So, any questions on the project? Yes.
The one that says geometric object, does it have to be geometric object?
You mean, can it be like a specific object or just? Yeah, you could do that. I mean, I think a good example in the previous one, there was, and people will have a tendency to do like the boxes that dance to the rhythm and like they glow or change colors or whatever. But one of the examples in here was a bunch of like hex head screws that were kind of like screwing like up and down like in a certain like so I mean, yeah, I think you could do whatever you want to object-wise. I intentionally kind of made it vague so it doesn't just have to be like boxes or cylinders or whatever. And if you have an idea that you're like, ooh, that would be neat, I am willing to be flexible on most of these, right? Like to like bend the wording just a little bit to be able to get something out of it. Any other questions, comments? So again, next 2 class periods are going to be primarily work time. The next class period is Thursday. I'll be in here. I'll sort of walk around, help you troubleshoot some of your ideas. And then we go on fall break and you lose all of your momentum. And so we come back, and that's why I gave you a little extra time there, is to rebuild that momentum. I would ask you to make an effort to come back from fall break, like hyped to hit the ground running. It's really hard to like get people energized for that next or for that same project. So kind of keep the energy going on that, and don't just put it off till starting that week. So, anybody, any questions, comments on anything? All right.
You have the Word file that we're supposed to do on each spot, right?
It's not a Word file. It's linked to a Google Drive or a Google Documents file, but it's the same thing, and you can download that as a Word or a PDF, I think. Yeah. So that is the other thing. It's like 4:20 right now. So you got time for a little break if you need before portfolios. It's really 4:21. I rounded down. I'm probably going to head out of here at about 4:40ish, a little early, just so I can run downstairs and get a drink and stuff like that. Huh? I think it's room 130. If you look downstairs, all over the walls, Radim has hung up a map to help you find it. So I'll hang around for a little while longer, but if you're wanting to go to portfolio, I would also maybe consider hopping out and grabbing a nibble so you're not like starving during the middle of this. But yeah, I'll hang around and help out with a few questions. Let me go ahead and stop the recording and upload that to YouTube though, because I have a feeling some of you are going to want to watch some of this again. So. And this time you can fast forward through the boring parts. Thank you. Where is
You
it?
have to write on the paper or just do a selfie?